Hi there. I have a question for you. Do you think that numbers could have powers? I'm guessing you're already thinking of magical powers or superhero powers. And did you know that the temperature at the core of the sun is 15 million degrees Celsius? That is 27 million degrees Fahrenheit. Astronomers say that there are around 400 billion stars in the Milky Way. You see that these numbers are very large, and I would say very, very powerful. When numbers get so big, calculations with them may become tedious. But guess what? Mathematicians found a way to go about this seeming problem. Welcome to indices. In indices, we use simple notation to make large numbers compact and easy to manipulate, yet maintaining their value. Large numbers turn out to be smaller numbers multiplying each other. For example, 1 billion can be 9 smaller numbers multiplying each other. 1 billion is 10 times 10 times 10, which is 10 multiplied by itself 9 times. This very large number, which is over 5 times the population of Nigeria as at 2016, can be represented as 10 raised to the power 9 by the help of indices. The number that repeatedly multiplies itself is called the base. And the tiny little number is what makes the number pretty powerful. So when we have 10 raised to the power 9, like in our example above, 10 is the base, while 9 is the power. Some bacteria have a diameter of 0.0000001 meters. Should we always write this out in full? Of course not. We can also have a quantity like 0.0000001 meters written with an index. To get the index, we count the number of steps the decimal point moves to the right to make the number a whole number. But the index will carry a negative sign. In this case, the number of steps to the right is 6. So the index becomes -6 and the base is 10 and not 1. So 0.0000001 meters can also be written as 10 raised to power -6 meters. This is what is called a micrometer. Writing numbers with indices enables us to easily work with them during calculation. Sometimes, for convenience, letters and symbols are used to represent numbers in maths. When this happens in indices, the letters and symbols are treated as though they are numbers. So in indices, we can have numbers like x raised to the power 3, y raised to the power -5, and m raised to the power 25. I bet you have never seen a number going to prison, have you? Well, it's because numbers are quite obedient and do not misbehave. They obey certain mathematical laws, and a good example are the laws of indices. These laws are nothing but patterns discovered by mathematicians on how numbers with powers behave during operations. Learning these laws will help you deal with numbers when they get so powerful. That is, when the number becomes so large and has a greater index. We will look into the laws in other classes.